I'm Ron Ponce. I'm the engineering and manufacturing teacher at Anaheim High School. I teach 9th through 12th grade, and I am a 2019 Orange County Teacher of the Year, and I enjoy what I'm doing. Been at Anaheim for going on my 13th year there. Teaching, I believe it's my starting my 20th. Okay, so what I was asked to do here was give some new teachers some ideas of how to get everything going. So the first question is, what is your strategy for developing your annual curriculum? First thing I do to develop it is I start to learn the students. What gets them involved? Use their past experience, what they like, to get their attention, because that's going to keep them involved. If it's stuff they don't like to do, they're not going to want to do it. So I balance that with what industry wants to develop the curriculum for the year. You use a basis of your curriculum and just tweak it a little bit so it works with your class. How do you keep students engaged with their projects from start to finish? There are hours of waiting time in 3D printing. What kind of challenges does that bring? I have more problem of the students actually wanting to get on the machine. Because what you want to do, you don't want to have them sitting there waiting on it, so have something else ready for them for when their project is printing. Because if you got 30 students that finish at the same time, they're not going to wait. So what you want to do is make sure you have something else ready for them, so while they're printing their stuff, they're already working on the other assignment. The only way you could do that is if you had 30 printers in your classroom. But we know that's not possible. Plus, when one goes down. And some prints are an hour long. Some prints can be 14, 20 hours long. I've had some go over 34 hours. With the new technology, it is getting quicker and better prints. So what I do is I just make sure I have some, okay, you finish this, now work on this while yours is printing. So that's how I keep everyone involved. Do you prefer to have students work individually on projects or as a team in a jigsaw process? Maybe both. And pros and cons of each. Okay, pros and cons of teams. Yes, it teaches people to work together because in a job you're going to have to. On an individual basis, you make sure that everybody's working. You make it exciting, and this is where it goes back to that curriculum, that you want to make sure it's something that keeps them involved. I do both. One of the things we're actually working this year, not just our school or my classroom, we're working with 3 different schools for a project that each school has to bring a different part of a project, and we will combine it there. So like they said, the jigsaw effect. So that should be pretty interesting. This is the first year we're trying it. But we want to make something that brings 3 schools together to show what we're capable of. Schools don't have to always be against each other, like in athletics. We like to work together. What method have you utilized successfully and failed with juggling with the students with such a wide range of technological aptitude? That is true. I get kids that can't do anything. I get kids that have been in a class for 3 years. And they're just taking it again. The ones that know a lot, use them as a peer teacher. As long as you know they do. A lot of people come in wanting to be a TA of a class. Well, if you don't know my curriculum, you can't do it. I don't need someone just to sit there and, take a trash can out for me or something like that. I want a peer teacher. Someone that knows how I teach a curriculum and that knows the curriculum. Do I learn stuff from students? Yes, I do. Every year I learn something new that I didn't figure out or didn't notice that I'll learn from a student. So yes, I do utilize the past students or a student that knows a little bit more. They may have come from another school. I do a lot of hands-on individually. I do not sit at my desk and just kind of lecture. I'll do a quick lecture, then I'm up around with them. So yeah, it may take time working with a student that's on the lower edge of technology, where you've got another kid who's zipping through this stuff. I've got special ed students that do fabulous. They just need a little bit of help. And then I've got kids who are, superstars in their attitude, but they don't understand the technology. So you will get all of them. You just have to find what clicks with them. Tips and tricks. I'll give you some tips and tricks with the machines. Yes, I do use mostly Airwolf products. And with some of the new stuff out, we're learning that we're actually, with some of the dual heads, because a lot of teachers don't do dual color. They don't use the support material in another color. We've actually started doing where we will do one part in with like a larger nozzle or a finer nozzle. So we have the dual head will have one size nozzle on one on the other, for not having to keep changing out. Like we'll do a print with a 1 inch on, for the Evos, they have a 1 millimeter, actually not a 1 inch, 1 millimeter nozzle, which will do big giant parts, but for the finer detailed parts, we may have a 0.5 or smaller on the other head. You just have to watch out which one you pick for in your software, in this case Apex, to what you're using for that printout. That's one of my big tips and tricks. Just do your homework. The machines, the technology is getting better. Working on a lot of new stuff. I like playing around, see what works, what doesn't. I've done everything from little parts that are an 1/8 by a 1/2 inch to parts that barely fit on the bed. And it just keeps working. If it doesn't, figure it out. There's a lot of people now starting to get a lot more webinars that can help you with this stuff. Technical people here at Airwolf, they're great. It's where I keep with the product. And they listen to you. I do sometimes have problems. Everybody does. But it's been great. I enjoy doing this. I want to be teaching for another 10 years plus. Hopefully that'll keep going. Technology just keeps getting better and easier. What about all the different technology of the different families of machines, types, different brands and stuff? They're all the same basis. Okay, you just like using the software for making these projects. Two big ones out is the SolidWorks and Inventor. Plus there's quite a few more out there. As long as you learn the basics, you'll figure out the rest. Right now there's so much out there on YouTube that it'll help you out. I go to YouTube myself on even stuff for the Airwolves. Okay, how do I do this? Boom, okay, great. That's how I do it. So yeah, each machine is a little bit different. You got your sizes of filament. Make sure you have the right filament in. Check all your settings. Make sure they're correct. If you got a dual head, make sure you're on your primary if that's one you want, or the secondary nozzle if that's what you want. That's the biggest thing there. Most beds, here's another good one. Do not use soap to clean your beds. Make sure just hot water. I'll use a razor blade, and I actually just use a paper towel. Make sure it's nice and clean. I've done that. Go right back to printing. Throw in Airwolf's spot, the Wolf Bite, and it runs perfect. But if you put soap on it at all, it puts that film on it and it will not adhere to it. Okay, materials. Make sure you're using a good quality material that sometimes watch your price. Yeah, I can get a roll for $10, but the quality is not good. It can plug up the machine, it can damage other things, or it won't even adhere well. Old material that's been in the air, it needs to get dried out somehow. Whether it's in a machine that's got a drying chamber, or you keep them zip-locked with some of those drying packets in them. But that'll do it. Make sure it's not too brittle so when it goes in, it snaps. Make sure that doesn't happen, because nothing's worse than a clogged head. So watch what you use. Don't always go cheap. Check what it does. Look at it. There's a lot of stuff out there, a lot of unique filaments, which I'm even playing with. But check the quality of it. Don't just go for the cheap stuff. Okay, the two most common products that are used in the high schools and even the colleges is PLA, polylactate acid, if I remember, and then ABS, which is, I don't even remember the actual term for it, but it's out there. ABS, you do have to have a heated bed. And you do want that bed to be at least 110 degrees, if not a little warmer. I actually went into an engineering firm that just went over to ABS and they couldn't get it to stick. The reason was the bed wasn't hot enough. So if you have one that doesn't heat up there, you're not going to be able to use the ABS. PLA, there's a lot of stuff out you can use. I've used everything from the Wolf Bite, I've used glue sticks, and I've even used painter's tape for PLA. And that works good. Just if you take that tape off after the PLA and you go back to a chemical, make sure you got that bed nice and clean again. You get all that adhesive out. So on your adhesion stuff, make sure you're using the right stuff. If you're doing ABS, polycarbonate, any other ones with a big odor, have your machine either some kind of filtration system or by a window. Nicest thing about PLA is it doesn't give. That one kind of smells like a maple syrup. So it's kind of funny. People have smelled that and, ooh, wow, I'm hungry. So you get all different kinds of things. If you got a lot of machines going, yeah, you really want to have some kind of filtration. If it's one or more, two machines, just don't have it right next to a student. You know, have it offset in like a manufacturing area or back in a corner where they don't get those fumes. And make sure windows are open. And also use fans if you need to. Not blowing on a part, but just blowing the air in the area. You got to make it fun for your students. I do know that even in my case, I get a lot of students that are dumped in your class. Find out what gets their attention. Some of those students just want to be acknowledged. So get them to build something that they like. You know, get them started, get them going, and they'll get the interest. You just got to find that little start. You know, you got to find that seed to get it going in each one of these students. You won't be able to reach them all. But I guarantee there's some that you won't think were reachable, and they'll change. Or you'll have some that never did in your class, but they'll come back afterwards and say, stuff you taught me, now I know why you did it. Those are some good things to think about. You'll get one of those individuals who really doesn't want to do anything. Hey, my friend's doing this, maybe I'll join him. And competitions are great. They want the acknowledgement. A lot of these kids, yeah, you're expected to do it, but then that's it. When they get acknowledged. Our school, we actually just took 8th place in the nation in robotics. And yes, we had 3D printed stuff on that robot. The test thing we did was Skills USA, Urban Search and Rescue. So we actually printed wheels that I didn't just want to wait for it. I didn't want to wait for a week for these wheels. I made them in a day. Yeah, I had to do a little work on them. Students actually did most of it. I just give suggestions. But they printed them out, they assembled them, and they're excited. They loved when they were at competition, other students going, where'd you get that? And they can say, I made it. So that gets them excited. That gives them the interest, the buy-in, is when they can use their mind to do it.